You might have heard about people saying about side effects. Side effects means mutability, that's all. When a function is doing some side effect, it means it is mutating. It's a mutability function. So we had seen the basic data types, I suppose. String interpolation we had seen. Tuples we did see on the tuples. We discussed on what is the expression. Again, expression was again boils down to the same immutability, which returns some value. Everything we can look as an expression. Expression blocks also again we saw where we write multiple expressions together. If we are writing multiple expressions on the same line, only we need a semicolon at that point of time. Otherwise, we don't need it. If we are writing on a multiple lines, expressions, semicolons are not at all required. And this is block of expressions. This is block of expressions. Again, contrary to expressions, we also saw that statements. Statements are unit of code that does not return a value. So if it doesn't return a value, its data type should be unit. That's what we discussed. We discussed that last session. We discussed about unit data type. It is just like void. It is just like void means it doesn't, if nothing is returned, the data type is unit. The statement data type will be unit. These are all the jargons just we need to remember. The statement data type is a unit. Here the statement is like a print. Println if I say, so it's a, this is a statement actually because print does not return anything. If you go back to C or C++ programming, C I think, C programming, print used to return the number of characters it did write on the console. But here and all, print does not return anything. We can check that. I can check val r equal to print, I'll just say 10. If you see, the data type of R is unit and its value is, if you see the representation, it is done in this fashion. Its value is this. Hence it means that println does not return anything. If it does not return anything, this is a statement actually. This is our statement. Similarly, we have if-else condition. Even if-else condition is a statement. Sorry, it's an expression. It's an expression here. So if I say if it's an expression, it has to return some value. When I say if is an expression, it has to return some value. So I will say it's equal to, if condition, I will say percentage. Here is a question now, is equal to 0. I will say by 2. I'm just saying a if condition here. This is my if condition. If 10% 2 is equal to 0, then return by 2. Return a string by 2 here. So the question here is, what is the data type of message? Question here is, what is the data type of message? We know that based on what value we assign, the data type of that identifier will be based on the what value we assign. Anybody else? Naresh says it is string. How about others? Ram, Sandeep, Sukesh, Venkat. Yeah, it looks to be a string, but there is a difference here. So let's try to see, execute and see what is the data type of message here. If you see the data type of message, it is any. This is how a data type is represented. The data type is any here. Yeah, it looks like a string, but it is a other data type, that is any data type. So how did we get that as a data type? It's all because of functional functionality. It is all about the functional programming. We know that if is also an expression and it has to return some value. So we are returning some byte as a string. So here if the condition is true, this expression will be evaluated. If this condition is false, this expression will not be evaluated. Either we should have an else condition, but we don't even have the else condition in our expression. We have just an if expression, and if this expression is true, this will be evaluated. If this is false, there is nothing to execute at all. If this becomes, suppose this is a false expression, if expression, then there is nothing to execute. In that case, there will be nothing to return. Nothing is returned if the condition is false. String is returned if the condition is true. So what I'm trying to say here is we are trying to return two different data types. Nothing is returned means what is the data type? Sorry, string is returned. String is the data type here. Here, if nothing is returned, unit is the data type. So we are returning two different data types based on the condition. If the condition is true, string is returned. String data type is returned. If the condition is false, since we don't have any code to evaluate, any expression to evaluate, we are returning unit. But we cannot assign two different data type to a message, an identifier. We cannot assign two different data type to an identifier. That's the reason it always gives the common parent data type. It always gives the common parent data type. Let's see what is the common parent data type here. If you see, this is the common. In the first, if the condition was true, we are returning string here. If the condition is true, we are returning string. If the condition is false, we are returning unit. So we are returning two different data type. But what is the common data type here? The common data type, the parent of string is any reference, but this is not the parent of Scala. Similarly, any value is the parent of Scala unit, but it's not the parent of Java. This is the common data type. hence any is returned here, since any is returned here. If we had returned, if the condition was true, if we had returned a character, and if we had returned something else boolean here, if the condition was false, if we had returned boolean, if the condition was true, if we had returned character, in that case the data type would have been any here, any value. The parent the common parent data type will be the data type. I hope you got, based on the return value, how the data type is chosen. Based on different data types, how the single data type is chosen. Any questions here? I hope the things were clear here. The if else condition, we can check that if the condition is true, I can say boolean true. If the condition is false, I can say integer something. So in that case, the data type will become any value. That's what we saw. So if we return in both the cases the same data type, I will say by 2, else I will say not by 2. So if you see in this case, both the data types are string. If the condition is true, we are returning string. If the condition is false, we are returning string. Hence the data type of message is string. So this is how that expression works. We always try to return some value. So any questions here on if expression, if else expression, any questions? Okay, no questions. No questions from Naresh. Next we have no questions from Ram. Yeah, next we have the match expressions. So we can, using the if condition, just a simple example that how to compute a max. Val max equal to if x, let's say val x equal to 10, then I will say val y equal to 20, then I will say val max equal to, I can check here if x greater than y, return x, else return y. So x and y are returned here based on which is greater than what. If x is greater than y, so just a simple way to compute the maximum of two identifiers. So this is a simple way, only difference is the data type. We always try to return something which is not true in other programming languages probably that we might have come across. Now we have one more concept called match expression. There is a concept called match expression which is similar to switch case in Java. Or let me not refer to Java. Let's say I have a match expression which is similar to switch in other programming language. We have a switch, we have some element here, then we have case, probably here could be some based on that element, then we have some break, then second case. This could be something like 10, I will say 20. I have some statements, then I have to break. Finally, I have a case with the default, some expressions, and that's how the switch looks like. Similar to this, we have match expression in Scala. But it is much more powerful than the switch case. That's because match expression not only works on the simple data types, switch cases only work on simple data types, either boolean or integer or a double or a string. Switch case works on simple data types, but match expression can be used not only on simple data types, but as well as on complex data types, like collections, like objects, user-defined objects, collections of user-defined objects, classes. We can do the pattern matching here. So it is a much powerful concept than switch cases in Scala. Let's see how it is defined. The syntax, let's see how the syntax is defined here. We will try to compute the same maximum. If else condition, we'll try to compute the same max. I will say max equal to x greater than y. We need to specify the expression before the match. If you remember in switch, we used to provide the expression here. The expression or the evaluate whatever we want to evaluate and check, that was part of the switch here. We used to provide it here. But in the match, we provide that expression here, just before the match keyword. So this is how we provide, then we pass it to the match expression. Match expression is a block here. We can write the case. Here what happens is, this expression will be evaluated. X is 10, Y is 20. This expression will be evaluated based on that evaluation value. That value will be passed to the match block. So what will be the value here? After evaluating this expression x greater than y, either it will be a true or false. Based on the actual value of x and y, either it could be true or false. So we will be doing a pattern matching, because the true or false will be sent to the match expression. We will be doing true or false pattern matching. This is a new syntax here. This separates the pattern from what expression we want to evaluate. If that pattern matches whatever is there on the right hand side of this arrow mark, that will be evaluated. Let's say I'll just say x. If case false, again double arrow mark, I will say y. So this is the syntax of a match expression. This expression will be evaluated, the value will be passed to the match block, and here we are matching whether it is true. We are doing a pattern matching whether it is true. If it is true, this expression will be evaluated and it will be returned from the match block and assigned to max identifier. Similarly, if this pattern matches, whatever is on the right hand side of this double arrow mark, this will be evaluated. This expression will be evaluated and that evaluated value will be returned and assigned to max. It is not mandatory that we only have to have a single expression here. We can have a block of expression here. So after evaluating that block of expression, whatever value we get, that value will be returned from the match expression and assigned to here. But here we are only having a single expression, so hence we get the max value. So x is 10, y is 20. So it evaluated to false. That false was passed to the match block. This pattern matching was false. It did not hold good. This pattern matching did hold good. As a result, y was returned and assigned to max. Y was returned and assigned to max. Yeah, the question here is break doesn't break is not required here. I mean to say there is no break kind of a thing in Scala. Whichever pattern matches, that will be evaluated. If that doesn't match, it will go to the next pattern match. If it doesn't match, it will go to the next pattern match. Whichever matches, once it matches, it will return from there. That's all. There is no break kind of a keyword in Scala. Right. The next question is, what about default? So we'll see how the default case is handled here. So let's take one more example. Let's say, I will say val status equal to, I will say 500. Or I will say 200 here. Then I will do val message equal to, I will pass this status to the match block. Status value will be passed to the match block. Here I will say case 500. Then I will say critical error. I will say case 200. I will say just success. Simple. As it was in the earlier case, we are doing the simple case here. What is the value of status? Status equal to 200. That 200 will be passed to this match block. This expression will not hold good, or this case expression will not hold good. Hence it will go to the next case expression. This holds good, hence success will be returned from this match block and assigned to message. This is what we learned in the previous example. Now suppose our value is 404. Our status is 404 now. In that case, what will happen? Let's keep the same expressions. Here now, this time the value is 404. Status is equal to 404. We have assigned it to status. Now 404 will be passed to the match block. This pattern will not hold good, nor this pattern will hold good. None of the pattern hold good. So in that case, we will get a error. So the condition here is at least one of the patterns should match. If none of the pattern matches, we'll get a error. Match error, that 404 does not exist. So how do we get rid of this errors? So there are two ways to get rid of these errors, and it is called as wildcard pattern matching. It is called as wildcard pattern. And there are two types of this. There are two types. First is value binding. First one is called value binding. Second one is called, we can say, the default case. Or you can also call it as underscore. The symbol underscore. So these are the two ways to do some generic pattern matching. Generic pattern matching, or we can say also as one of the cases is a default case. If nothing matches, underscore will match. So just before that, we'll see what is value binding. What is value binding? So we'll take the same example here now. We have status is equal to 404. We have this. We are having the match expression in this fashion. 500 means critical error. If it matches 200, it is success. Or I will say case X. I will say unknown here. So this is what we call as value binding. What happens here is, again, the status message will be passed to the match expression 404. It does not match here. It does not match here. Now later what happens, that 404 value will be binded to this X. In the match expression, that 404 value will be binded to this X. So now X is equal to 404. When we do a binding, it means it is pattern matched. When there is some binding, it is assumed to be a pattern matched. Hence this pattern matches, and we will be returning a unknown. Whatever is expression on the right hand side of the matched pattern, that expression will be evaluated and it will be returned from the match expression and assigned to the identifier here. So this is what we called as value binding. We just specify some identifier, that's all. Just specify some identifier. X is some identifier. We can specify Y, Z, ABC, anything. So whatever value we pass, that value will be binded to this identifier, we can say. And binding of an identifier is nothing but pattern matching. Binding an identifier itself is a pattern matching. Hence this matches and we are returning unknown from here. So this is how but what is the use of value binding now? Why do we need a value binding? So usually value binding is used to do some further validation. Or we can use that because we know the value of X is 400. We can use it in our expression here. That's what we say as value binding. We can use that identifier in the expression on the right hand side. Somewhere we can use it as an expression. So I can say, let's say, again I will do the match expression, case 500 critical error, case 200 success, case X I have, then I will do some more pattern matching here. If X equal to 404, if X equal to 404, I will say not found error. Okay. So this is how I am using here. So if you see, immediately after binding, I am having an if. This is called pattern guard. It is called pattern guard. Immediately as we do a binding, we are checking whether X is equal to 404 because value 404 is binded to X. Whatever value we pass to the match expression, that will be binded to X. That value we are checking whether is equal to 404. And it is immediately after the binding. The if pattern guard, the if pattern guard is immediately after the binding, and this whole thing has to match here. Earlier what I said, if the binding happens, the pattern is matched unless we have a pattern guard. Here the whole thing has to match, like the binding is happening now, and also this condition has to be true for this whole case expression to be matched. Only then this expression will be evaluated. In our case it is true, it matches. So hence we got not found error. This time this expression got evaluated. Hence we got not found error. So this is the use of value binding so that we can do further validation, as well as we could have used that value or identifier as a return value also. I could have used it as a return value also. Using this string interpolation, I'll just try to get that value. So if you see not found error 404. So it is like we can further use that identifier for further validation or for some other logic that makes sense. So this is what we call as value binding. So let's change again. Let us change it to, let's change the status to 302. Let's change the status to 302 this time. And we'll give the same expressions. Pass the status to the match expression, check whether 500 it is, do a pattern matching on 500, do a pattern matching on 200, then do a value binding and check if it is equal to 404. If it is, then return this, then close the match expression block. So this time what will happen? What will happen this time? This expression will not match. This case will also pattern will not match. Value will be binded to X, but this will also not match. Since this doesn't match, since it is not 404, this pattern match also will not work. None of the pattern matches works in this case now. If none of the pattern matches works, again we will have a error. Again we will have the error, match error. As I said, at least one has to match. At least one has to match. So how do we get rid of this problem now? This is where the default case comes into picture. We saw this type, value binding we saw, and we know why value binding is required. And now we are seeing how to use the default case. If nothing matches, default will match as in other switch expressions. We'll try to give the same expression now, but we'll add extra things. I will say case underscore, that's all. I will say unknown. I will say unknown error. We don't know what is the use case here or what is the value. We are just saying unknown. It means if none of the pattern matches, the underscore will match. Underscore is our default case. So there will be lot of underscore that is being used in Scala as well as in Spark, and based on where, in which context the underscore is being used, the meaning of that underscore will differ. We can also, if you remember, in some programming languages we do a import the packages, and the end we will do dot star, import dot star. Some package will usually do import like package, some package IO, I will say Scala, sorry, I will say Scala dot IO dot source dot star. Usually we do here underscore. In other programming languages we used to do star. Star means all the classes of that packages will be imported. Similarly in Scala it is underscore. All the classes in that package will be imported if you do an import. So based on where in which context the underscore is being used, the meaning of that underscore will differ. Here it is a default case. I hope the match expression was clear here. Any questions on match expression? Any questions here? Yeah, Venkat. Right? Oh, okay. I think here val message, right? Actually, it is recreated here. If you see val x equal to 10, when I say, I can also say it is only valid in this console, Scala console. I can again say val x equal to 30. The same x is being used here. It means here it is recreated. The earlier one is destroyed and it is recreated. So, but if you just say without having the val, if you just say 6 here, this is a immutability. So this type happens only inside the console in the Scala REPL, but it does not happen. It will give an error in the actual Eclipse or IntelliJ. It will say the error that X is already defined. That's what. Here it will be recreated in the REPL, Scala REPL. It recreates. So that's the reason I was always trying to recreate it. Yeah. Other than that, anything related to pattern matching, match expression? Any questions related to match expression? Yeah. Here it is. This is the simplest form of match expression because we are doing an valuation or a pattern matching on simple data types. Integer here, integer here. Value binding. There are two concepts that we learned as value binding and underscores. Underscore is as a default case, but this is the simplest pattern matching here because it is done on the basic data types. Going forward, we'll learn how to do pattern matching on collections, how to do pattern matchings on a class object, how to do a pattern matching using class on the class object. So those are a complex pattern matching, and pattern matching supports all those things. So these are all the things that we saw. Matching with pattern guards, putting some conditions is nothing but pattern guards. This is what we saw. We can have any conditions here inside our pattern match. We can also do a pattern match on the type. We can also do a pattern match on the type here. Let's see how can we use the pattern matching using the how can we determine the type of an identifier using the pattern match? Let's say I have val x equal to 100. If you see, x is integer. Automatically data type is inferred as an integer, and we know that. What I will do is I will say val y. I will say the data type of y as any. The data type of val as y as any, and to which I will assign x. We always know that x is a subclass of any. So we can create an object of that subclass and assign it to the data type of parent class. So let's forget that parent and child. Let's say we are saying x is being assigned to y and y data type is any. But now I want to determine what is the data type of y. What is the actual data type of y? Because we are assigning value 100, the actual data type of y should be integer. But there is a other data type here. So we can use the pattern match expression to evaluate or know the data type of a certain identifier. Let's say I'll say data type equal to, I will pass y to the match expression, and I will say case, I will do a binding here, then check whether the data type is string. So I can say y is string, I will say. Case, again bind to z, I will just check whether it is double. If it is double, I will say y is double. Similarly, I can say case z. This time I will just put integer. Here it will be y is integer. So this is how we can use pattern matching to determine the data type of y. We don't know what the actual data type of y. Actual data type, if you see it, it says it is an integer. It is actually an integer, but here it is said as a any. We have defined it as any. We want to determine the actual data type here. So y is evaluated. We know that this expression will be evaluated first. After evaluating the expression, whatever value we get, that value will be passed to the match expression. So 100 will be passed to the match expression. 100 is an integer. So this case will be checked. 100 will be binded to z, and it checks whether it is a string. It does not hold good. It will bind it to z. It checks with whether it is a double, which does not hold good, and it will be binded to z again, and it will check whether it is an integer. This time it holds good because 100 is an integer, hence y is integer, we can know. It is just like we using is instance of. If at all anybody is familiar with Java, so there is one more called is instance of. But if you are not familiar, just forget it. We can just say that using the match expression, we can determine the data type of some unknown data type. We can determine the actual data type of some unknown data type. I hope you got how match expression is being used to determine the data type here. Any questions? Any questions on match expression? I hope the things are clear here. Okay. Yeah, next we'll see loops. We have for loops in other languages also. And the Java thing is also supported in Scala. like for I is equal to 0, I is less than 10, even that could be written in Scala. Like we have for, usually we have I is equal to 0, I is less than 10, I plus plus. This is also a valid syntax in Scala, but we'll not go through this because everybody knows about it. There are some more extra things that are available in Scala which makes for expression in a much better way to use it. So let's see what are all the new things here on the for expressions. So the for could be written something like this. I will say for, there is a new syntax here now. I will say I reverse arrow mark. Reverse arrow mark, I will say 1, 2, 7. So this is how we give it, 1 to 7. 1 to 7 will generate a collection or kind of a list, and each element from 1 to 7 will be generated and assigned to I here. In every iteration, a new element will be assigned to I here, and we can just print the contents of I. So this is how we can do it. Or I will say, so I can say in this format. So it will be looping from 1 to 7. As usual, for is for a looping, but the expression is different here. 1 to 7 will be generated. It's like an iterator. Each value of that iterator will be assigned to I, and based on what we specify here, this is the body of the for expression, and we are just printing the contents of the I, just transforming I to day 1 here. So this is how we use it. Here there is one more thing that we can use, until. We have 1 to 2. Similarly, we have until. Until means the last will not be included. 7 will not be included here. Only up to 6 we'll have. We'll have only up to 6. So this is how the for loop works. So I will call it as for expression, because every time we'll refer anything as an expression. For is also an expression here. So but how do we, if you see, the by default incrementing value is 1. If I want to increment it by 2, how do I do it? If I have to increment it by 2, how do I do it now? So we have to just say by 2. By 2. It will increment by 2 here. 1 until 7 by 2. Similarly, 1 to 7 by 2. Or if you want to increment by 3, give increment by 3. It will be incremented by 3 here. So I hope you got the for expression. Are these until 2 by R functions? Yeah, we will come to that. Just hold on to that question, Ram. We will come to that, what actually these things are. Yeah, that's a good question. Just hold on to that question. I will come to that question. Similarly now, this is a positive increment. Suppose I want to go from 7 to 1. Suppose I want to go from 7 to 1. How do I do that? Let's say I will not increment it by 2. I will just say 7 to 1. Will this work here? Let's try to print it in this fashion, 7 to 1. So, but we did not get anything here. Why we did not get anything? Because it was by default increment was plus 1. By default increment was plus 1, which never happened. Hence, we have to say by minus 1. We have to say here by minus 1. So it will decrement by 1, and now we are able to get the values. 7, 6, 5, 4, 3, 2, 1. So this is how we go in the descending order looping expression, and if you want to go in the ascending one looping expression, just use the other one. Default is ascending, and if you want to go in the reverse loop, just use the minus sign there. Just use the minus sign. Any questions here? All clear. So actually, let me take that Ram's question here itself. I was about to clarify that later. Here, we said that Scala is a functional programming language, but Scala is also pure object-oriented program. So I'm stressing here on the pure object-oriented. Actually, Scala is a hybrid of both functional and object-oriented. But the object-oriented part is again a pure object-oriented. So what do we mean by pure object-oriented is anything that we create in Scala is an object. It is an object. Anything. Whatever we create till now, whatever we created in Scala, everything was an object actually. When I said val x equal to 10, x is an object of type int or of class int. When we say val y is equal to 2.5, again y is object of the type double or of the class int or the class double. There is a double class and y is an object of that. There is an integer class and x is an object of that class. So everything is a pure object. Here Scala is also a pure object oriented program. And when I say like val x equal to 10, val y is equal to 20, and I say val z equal to x plus y, it means x is a object, y is an object, and plus is a method here. Internally what happens here is x dot plus method will be called, to which y will be passed as a parameter. There is nothing like operators in Scala. There is no operators in Scala. Everything is a method on a particular object. In this case, plus is a method on the integer object. X is an integer. We have a plus method inside the integer class that takes one more integer as a parameter. So this is our syntax here. If you see, we are giving x plus y. This, what does the syntax say? The syntax says we have an object, space, we have a method, then we have one more object that is a parameter. So this is also a syntax. We can specify object, we can specify method, and we can specify parameter. So the same thing is happening here now. If you go to the for loop, the same thing is happening. Let's take the same example. When I say 1 to 7 to 1 means 7 is an object on which 2 is the method that is being called, because we can have space just like x plus y. X is an object, space, method, space, parameter, because internally it will be calling in this fashion itself, and we have represented in this format. So similarly here what happens, actually it is 7. On 7 we are calling two method to which we are passing 1 as the parameter. We are passing 1 as the parameter. So it's the same result. What happened? Okay. It is a negative, right? I will take 1, 2, 7. So internally it is nothing but an object. On that object, 2 is the method to which we are passing 7 as the 7 object as the parameter. Similarly, on this we are calling by method to which we are passing, if we want to increment by 2, we are passing 2 as the parameter. So it will increment by 2. So all these are methods on that object. 1 to 7, I will just say val r 1 or 3 to 10, something, 4 to 10. So actually it returns a collection, a range collection, just a collection it is. It returns a collection, or you can say an iterator, and each value of that collection will be assigned to I, and it will be looping till the end of that collection. The for expression will loop till the end of the collection. On this range we have the by. So this is how, let me see whether it is on the range itself. This doesn't make sense to have a by here. Probably it only holds good with the for expression. You don't have a by here. Yeah, steps it is there. It says there. So I can pass something here. So it will give a range of this pattern. So this is what is happening here internally. So all are objects. That's what Scala is, a pure object oriented program. Anything that you create is an object, and all other things are the methods on top of that object. 2 is a method on integer object. Similarly, by is an method on the range object, because this returned a range. This returned a collection. On that collection there is a method by 2 and we are calling this. But we can also use it in this syntax. This syntax also holds good. Sorry, again 1 to 7. This syntax looks much easier. Instead of doing 1.2, then passing 7 as a parameter, then saying dot by parameter, instead of this syntax is much more elegant. I can say by 2 here. This syntax is much more. I hope the things were clear here. Okay. Similarly, we can say, let's say I have val s equal to I will say Scala Java some string. Then I will say val s1 equal to s dot contains. Contains is a method that will check whether a particular Ram, I didn't get your question. It says syntax sugar, how it works in Scala. Can you elaborate on the question? One second, just a second. Yeah, I got it, syntactic sugar, but what was the question related to syntactic sugar? Okay, you wanted to look it later, so we can look it later. Oh, okay, okay. Yeah, we can say that it has been made to look a bit easier, elegant way of programming. Right, right. Yeah, as I was saying, let's say we have a contains Java, I will say. Scala, we are checking, there is a method like in the on the string we have a method contains which checks whether this string exists inside this string. Obviously this string exists will return a boolean. This is a normal syntax. This syntax can also be given in this format. Like a plus x plus y we gave, the same syntax can be applied here also. Object space method space the parameter. So this is also a valid syntax. It will give the same result. So either one of them can be used. If you get confused with this kind of syntax, means we need to get used to that. We will see such syntaxes being used in Scala application or Spark application. It means nothing but a method is being called on an object and a parameter has been passed. So if you want to pass, this holds good for only a single parameter. If there is a multiple parameter that method takes, we need to again pass, have the open bracket and close bracket. This will still be there. I don't remember any of the method that takes two parameters. Contains is one. What else is there? Contains, concat, compare to, ends with, starts with. Replace we can check. We can check replace. I can say uh, Java I can replace with, I think, Ruby. I will just give this. So Java has been replaced with Ruby, but I cannot use in this fashion. This cannot be used in that way of syntax. Parameter, this will give a error actually. So that syntax that we learned, that cannot be used for multiple parameters, but we have to have the comma and check. Let me check. I haven't checked that. No. So in that case, we have to pass it in this format. So this way, it will take care. So wherever we have the single parameter, that works. Yeah. Keeping this in mind, let's move ahead with our next thing. I think for iterations, there are few things about, yeah, again, we also said that for is an expression. When we said for is an expression, let's check whether it returns a value or not. We did not check here. We just printed the contents of in the body. We did not check whether for returns any value. What is the shortcut key to get to those commands? I didn't get the question, Sukesh. Which commands? Oh, the methods you are saying. Yes. Okay. Yes, there is a, after the object, press the dot, then press the tab. Just press the tab. So we'll get all the methods associated with that object. Yeah. So I was saying about for expression. I always keep on saying that for is an expression. Let's see whether it returns any value here. We didn't check whether the for returned a value. Let's say val, I will say, just say a message equal to for, I will say I, and I will loop from 1 to 7, and I will just say println. Obviously, it make, you may have guessed what will be the return here because of the print statement. So we printed here, but if you check, the return data type was unit. It means by default for does not return anything. I'm using here by default, but we can make it to return some value. But here by default for expression does not return any value. So how do we make a for expression to return a value? We can make a for expression to return a value by using one more keyword called yield. So yield is a keyword here and before the body of the for expression. It is between the for expression and the body of the for expression. There is an optional keyword called yield. The yield is helpful in making the for expression to return some value. So let's see how that value is returned. I will say a string interpolation here and I will say day and I will use dollar to evaluate the value of I. I will use the dollar to evaluate the value of I. So what will happen in this case? So if we see it, what happened is whatever expression we gave in the body of the for expression, that expression was evaluated. After evaluating that expression, whatever value we got, that value was collected in a collection. It was collected in a collection and the end of the loop, at the end of the loop, the whole collection was returned from the for expression and it was assigned to the message. So for it starts from I equal to 1 to 7. When I is equal to 1, the body of that for expression gets evaluated. So what is the body? We are just getting the string here. Day, we are having day and value of I, day 1. So that gets collected in a collection. Again it will loop to the second element and again the second time this body gets evaluated and whatever value we get, again that will be added to the collection. Similar way till the end of the loop, all the evaluated value will be collected in a collection and at the end it will be returned as a collection. Hence for also returns a data. For also returns some value, but it in the form of a collection. It returns in the form of a collection for every value that it loops over. So we can imagine it in this fashion. We have 1, 2, 3, 4, and 5. Let's take only 5. So we are having this data here. So what would we transform that into? We said it transformed into day 1. We transformed it into day 2. Transformed into day 3. This was day 4. And this is day 5. Or that's why I'm making this day 4. And this is day 5. So this is our for loop with yield expression. For with yield looks in this fashion. It transforms each element in the source to a one more element in a collection. It transforms each element in the collection to a some other element in the collection based on what expression you give in the body of the for. What expression we give in the body of the for, or we can say some f of x we can say. So it does a one-to-one mapping, which is nothing but our set theory, mathematics set theory. So we learnt about set operations, where we transform our data from one form to another form. So this is what we achieve with for with yield. It is same as in the MapReduce also. In MapReduce also it's the same thing. We transform the data from one format to another format. So this is a very important concept here. Mapping from one form to another form, which is achieved by for expression. The same concept is being used in Spark as well. There is a function called map which achieves this whole thing. Internally we can say for with yield expression is done with the match expression. There is a function called map. In Scala, a function, we can say that for with yield is internally implemented as a map expression where it does a one-to-one mapping. One-to-one mapping is done. So this is with our for with yield. Any questions here on for with yield? Yeah, again, it returns a collection. Vector is a collection actually. We will learn about collection, this collection when we start with collection. Just you can imagine now, vector is just like a collection, just like we have array or list. We have those collections. Vector is one such collection. We'll look into that later. I hope for with yield was clear here. It evaluates this body and returns everything as a collection. So we can make a for expression to return some value. Any questions here? Any questions on for expression?
Pramod, one question I have.
Yeah, Rajnika.
In the yield, you're saying yes, right? That is just because of the string, right?
Right. It's a string formatting.
Okay. For example, if I want to, is it a kind of typecasting kind of thing?
No, it's just a formatting.
Formatting.
We use a percentage s in printf statements, right? Right. It's a kind
Yeah.
of thing. We are evaluating the value of I here
Okay. So
using
this
the dollar symbol.
yield function is only for strings, right? I mean, what
Come
you
again?
said, right? So this yield is kind of only for strings, right? If you want to work
No.
with strings.
Yield is to make for expression to return some value.
Some value. Okay. Okay. Got
Yield
it.
is
Yeah.
to make it to return some value. It is not,
Okay.
here we can have anything. Here I can
Okay.
just
Okay.
say, I can remove this. I can say I plus 10. Each value of I will be added 10 and it will be
Okay.
returned as a collection. So it will become
Okay.
11, 12, 13,
Got
14.
got it. Got it. Yeah. Yeah. Got it. I thought like S is kind of string
S is
kind of thing.
here we can say val just simple message one I will say the value of something, or I will say val y equal to 45. I can say val message 1 equal to, it is just for formatting value of y. I can say equal to dollar symbol y is used to evaluate that value. So just for string formatting, that's all. A yes keyword is used. Yes
Okay,
letter is
okay,
used
yeah,
for
got
just
it.
for formatting. So that's what
Okay,
we are
got
trying
it.
to
Thank you.
format here.
Okay.
Yeah. Any other question here? Yeah, if there are no questions, we'll move on to some more things on for expressions. We saw how the yield worked. We are still, we have to just see what is a vector, but as of now, just hold on to this question. Just assume this is just like a collection. It is a collection. We will see it when we learn collection. So without yield, for does not return anything, but with yield, for returns something. That's all. So here is how we use a pattern guard. Sorry, not a pattern guard. In pattern matching, in match expression, we saw guard. Similarly, in for expression also we have a guard, and it is given in this fashion. So here is an example. We'll just take that example. So if here we are giving a condition, so such conditions can be given in the for expression. It is also a valid syntax. These are also valid syntax in Scala. Even though these conditions can be given in the body of the expression, it can also be given in the for expression. So it will iterate from 1 to 20. For each value of I, we are checking whether it is divisible by 3, only then yield those I. Only yield those values of I, hence we'll get only the multiples of 3 here. Multiples of 3. So we can always use the if expressions here, or it is usually called as guards inside the for expression. Like we had our guards in the match expression, similarly we have the guards in our for expression. So these are all valid syntax in Scala. Yeah, here again, if you see, we always said that we did 1 to 20. What it gave, it actually gave a collection. 1 to 20 actually gave a collection. It means on the right hand side of this reverse arrow mark, there has to be some kind of iterator or a generator. Need not be always a range collection. It could be a vector collection as well. It could be a vector collection and any collection. If you see our threes, our threes is a vector collection. I can use this threes in the for expression. I can say I threes, and I can just say println I. It will, so each value from that vector will be generated or iterated and assigned to I, and it will keep on moving to the next. So on the right hand side of this reverse arrow mark, we need to have some kind of a collection or an iterator or a generator, we can say. So similarly, we are seeing here one more example. a method called split. Using the method called split, it will return an array. The split method will return an array. If you see the quote, we are having a string here. We can just show it here. I'm having a string as quote. It is a single element string or a single string here, which is in this format. If I do a val a quote equal to quote dot split, I am doing a split with comma here because it contains comma between each words inside that string. I am doing a split on that. Each word will form a element of an array. The split will return an array actually. So array is again a collection. Array is again a collection. We can use this array inside our for expression. We can use this array in our for expression just like we use other vector or range collection, because on the right hand side it could be any range collection or it could be any iterator or a generator. So this will return an array on doing the split. Each element of that collection array will be assigned to T as the for loop goes forward or loops, and we are checking whether it is null, not null, and we are also checking whether it is greater than, the size is greater than 3. We can have multiple conditions like this. We could have multiple conditions like this and it works fine. So we are checking only the, so in a single if conditions, no, in between this is actually both the conditions are checked here. Okay, 1 second. Println, I will say, or I will say yield. I will just say yield T, which will give the fate. Let's check whether it works on a single condition. Whether I can give it if T is null and T is dot size greater than 3. Let's see this works or not. I will say yield T. So it gives the same result to us using the AND or. So we can either use or and all those things. The thing is we can provide conditions inside the for. Not only we can give it inside the body, which is the traditional way of giving the conditions in the body of the expression, but in Scala we can also specify such conditions inside the for expression itself. That's also a valid syntax. So in the, usually we give it in the body, right? We will do, we'll take this. What we can do here is we can see yield. Here in the yield I can say if T is not equal to null and T dot size is greater than 3, I will say yield T here. I'll say T. Okay, there may be something here because what will be the else condition? The data type may be yield. What did I do? My mistake. Let me clarify it. We have a for loop, t equal to this. I just loop this. I will do yield. I'll just specify if condition. I'll just say t. Let's see what value we get. Yeah, here is the difference. It returned a t here. It returned a data type as any. That's the difference we are getting here. If we are putting it inside, because it becomes a normal if expression where if and else has to be given to determine the data type. Since if this condition is false, it returns a unit. If you see, the unit value is open bracket and close bracket, because there was one element whose size was less than 3. If you see, which was that? High was an element whose length was less than 3. So for that the condition was false. In that case, it returned a unit, and the value for that unit is open bracket and close bracket. So this is what we get when we put it inside the yield, because everything will be collected. Either it is true or it is false. Not everything will be collected. If condition has to return something. Either it is true, it will return something. If it is false also, it has to return something. So in case of false, it has returned unit. In case of true, it has returned a string. I hope here how we got this open bracket and close bracket. So it's better to use inside the for expression itself. Or you make sure that you have a particular else condition also. Else also I could say t again, but that doesn't make sense. I hope the thing was clear here. I took a diversion, but I hope things were clear. Naresh, I hope the things were clear, right? Okay. So we can have multiple expression inside the for expression itself. So that's what we saw in our case. Like we can have multiple such expressions, we can also have a nested expression. If you see our nested expression in other programming languages, how does it look like? Nested expression in other programming languages. We will have for I is equal to 0, I is less than 10, suppose, I plus plus I will do, open bracket. Again inside that I will have one more for expression, j is equal to 0, j is less than I will say, then again say j plus plus, open bracket. Probably I will print I comma j. So this will be our nested loop or nested expression, we can say. The same thing can be achieved in Scala with this syntax. This is the syntax for nested loop. First expression, then the next expression. That's all. So for each value of x from 1 to 2, y will range from 1 to 3. That's what we are trying to do here. For this expression, we are printing x comma y as a tuple string. We are printing x comma y as a tuple string. For each value of x, for each value, like for x as 1, we'll be looping from 1 to 3. X is 1, we'll be looping from 1 2 and 3. Again next for x value 2, we are looping from 1, 2 and 3, which is nothing but our nested for loop. So this is the syntax for nested for loops, a bit different from other for expressions. So a bit different from other for expressions. So this is how we use the nested for loop. If we use a yield, it will return a yield of, it will return a collection of tuples. It will return a collection of tuples if we use a yield instead of print. So here I can say yield, the same thing. So it will return a collection of tuple here. This is a tuple. So it depends on how what you want to return, or if you don't want to return. Based on that you can use the keywords, and also conditions can be specified inside the for expression itself. Similarly, we can do a value binding. We saw the match expression that we did a value binding. The same way we can do a value binding in the for expression itself. We'll have this condition and we are assigning some value. That's all, as simple as it looks like. Not a big deal here. We are assigning some value inside the for expression, even though we could have assigned this value in the body of the for expression. We have used it inside the for expression itself. Here we need not worry about the logic here. The logic is nothing but bitwise shift operator, left bitwise operator. What this arrow mark is as usual in other programming languages, left bitwise operator. Each bit will be shifted to the left hand side, which increases the value by power of 2. It will increase the value by power of 2. That's the logic here, but not to worry about that, because here we are just saying that we can assign some value to an identifier inside the for expression. Inside the for expression, I will just say yield POW. It will return a collection of multiples or exponential increase of the or power of 2, because left shift will do a power of 2. Left shift operator will do a power of 2. So this could have been done the same way here. It could have been done in the yield. I could have said instead of this, I could have said val POW equal to 1 colon left shift I, then return POW. So I had to do in this fashion. Whatever was the last expression, that expression will be returned from the yield and collected in the collection. Always when we give a block of expression, the return value is always the expression which is the last expression in the block of expression. After evaluating that expression, the value that we get, that will be returned, but since we are using a yield, that will be returned and collected in a collection. So instead of giving in this fashion, the same thing we gave inside our for expression only. Instead of giving in the body of the for, we have assigned a value inside the for expression itself. So this is also a valid syntax in for expression. And yield has returned the value here. So any questions here on value binding? We will skip while loop, because while loop is similar to any other while loop. Just you loop through the while loop, but we cannot return anything. it will be always an X statements. While loop does not return. We just use for modifying something, for mutating something. It does not return anything. Like we had for with yield, which made the through which we could return some value from for expression. While does not return any value. Just it's like a simple other things. You can try it out. If you face any difficulty, just let me know. The while expression. I hope the things were clear here. Till here for expression, I hope for expression was clear. Match expression was clear. How different things were happening on for and match expressions, I hope it was clear. Next we'll define functions. Later we'll go to some more complexities inside the function. Let's define simple functions now. This is how we define a function. This is also a valid syntax. Def is the keyword that will be used, just like we use in Python, def keyword. This keyword is used to define a function. If you are not passing any parameters, we need not specify open bracket and close bracket. It is also a valid syntax. Open bracket and close bracket is optional. If we are not passing any parameters, we need not specify any parameters. This is a valid syntax. Again, the equal to sign is like to say that functions also return some value. Functions also return some value. That's the reason we have a new way of writing the functions, where the function name and the parameters is differentiated from the body of the function using the equal to sign. It is just a symbol to say that functions also return some value. Even if it does not return any value, there will be some value returned. Unit. Unit will be the data type, and we already saw what is the value associated with unit data type. It is just open bracket and close bracket. The value associated with the unit data type, it means that even if you don't return any exact value, something will be returned. Something will be returned. Hence we have an equal to sign in between the body and the name of the function. So this is a valid syntax. I can say a valid syntax. I can call this, I'll just make it hello scala, so that it is. When I call this function, this is how I call the function, that's all. And it returns a string. I can assign it to some value, message, val message equal to, I will call this function here. So when I call this function evaluates and returns hello scala. And that return value is associated or assigned to the message identifier. And the data type of message identifier is automatically inferred as a string based on what value is being assigned to that message. And we saw that earlier. The inference is automatically done here. And again, the return type of the function, the return type of the function is always whatever is the last expression's return type. What is the? Yeah, no problem, Rajnikant. Sure. Yeah, this is a valid syntax. We can have in this fashion also. This is also a valid syntax for the same function. For the same function, I will say hello scala here. If you see, we are specifying the data type here. This data type is again the return data type. What is the return from this function data type? So it is again optional. Again optional, and it always, as I said earlier, the data types always comes at the last. If you go back to other programming languages, we first specify the data type, return data type, then we define the function. But in Scala, the data type always comes in the last, as said earlier, because the compiler will automatically infer the data type, but still if you want to give, we always give it at the last. Here the data type is string, the return data type. And again it is optional. Again it is optional. So I can say call hi here, it will return a string. Hi returns a string here. I can assign it to some message equal to hi. So we can drop that string here, which we have already done. We can also drop this parameter if we are not passing any parameter. We can also drop open bracket and close bracket, which is the first thing that we did. All these are the same things. All these are same things. We can get rid of the unnecessary redundant things can be removed automatically, can be removed, but the compiler will generate them automatically. It will infer them automatically, not to worry about those things. Any questions here on functions definition? These are some of the simple functions. I can also define a function as a max. I will say var def max. I can pass x as a first integer, y as the second integer. I can say if x greater than y, I will return x, else I will return y. This is a simple function definition which takes two parameters and it returns some value based on the condition here. This is the body of our function. If you see, the body is separated by the equal to sign. And we don't have to specify the return keyword. Again, that is optional and the compiler will take care of that. Wherever we could make simple mistakes and go long for compilation error, to get rid of the compilation error, we will be going lot of times. So all those simple mistakes that could be done, all those things are bundled together and put into the compiler itself. The compiler itself take care of that so that we can concentrate more on the logic here. So that's the beauty of Scala, we can say. So here we don't need a return expression, a return keyword. Whatever is the last expression in the body of the function, that will be the return value. The evaluated value will be the return value. Here either we return x or return y, and both the data type are integer. Hence, if you see, this function's return type is an integer. It was automatically inferred that the function's data type is an integer. But I could have also given it explicitly like int. Both are same. Explicitly you can give, or it will be automatically inferred by the compiler. This is how we define a function, and this is the traditional way of calling a function. A traditional way of defining a function and a traditional way of calling a function. So going forward, we will see much more complex things about functions. Yeah, like we saw expressions and statements. We saw expressions and statements. So we saw similarly there are functions and procedures. There are functions and procedures. Expressions will a unit of code that returns a value. Statements are also expressions, but they don't return a value. That was the difference. Similarly, functions are the one which return a value, procedures are the one which does not return a value. These are all just jargons, again boiling down to returning some value and not returning some value. Returning a value means immutability, not returning means it is always about mutability. So again it will boil down to immutability and mutability. That's all. Just the jargons are being given here. The final concept is mutability and immutability. Uh, Naresh, yeah, which part, Naresh? Yeah, expressions are nothing but a line of code or a unit of code that will return some value. We saw that expression if is an expression because if also returns a value. For also we can say an expression, for also returns a value. We can say val x equal to y plus z or val z equal to x plus y. This is also an expression because after evaluating this expression, we return some value and assign it to z. So all these things we can call it as an expression. Statements are contrary to that, which does not return any value. Difference between function and method in short. No, functions are independent. Functions are independent. Methods are associated with the objects. That's all. Functions are independent and methods are associated with the objects. It's just we can jargons that we use, but if we know the concept, that's all. We can call the methods also as functions, but the confusion arises. One is associated with the objects, the other one remains independent. The pure functions that we are discussing now, these are all functions. These are all pure functions where it is not associated with the object. The method, just like a method. When I say Scala is a pure object-oriented program, everything is an object except that method, except the method defined inside the class. It is not a object. We cannot have that as an object at all because it will go on for a continuous loop, infinite loop, because if that becomes an object, again it has to have some method. Again, it will go on a continuous infinite loop. The methods are never an object, except that we'll say everything that we create inside a object, inside a Scala is an object. Yeah, that's the difference, functions and methods. Similar to that, I said procedure is nothing but procedure is also a function which does not return any value, which is usually used to update something or modify something or write somewhere to the external entity somewhere. So that's what we call as a procedure. So here if you see, we have defined a function log which just prints. The body of this function is a print statement. The body of this function is a print statement, hence this function becomes a procedure. This function is actually a procedure because it print will not return anything, hence this function will also not return anything. This function return type will be unit. This function return type will be unit, hence this function is called as a procedure. It's only the jargons. It's all about doing mutating something or completely returning some value. Immutability and mutability. That's all. Just keep in mind that it is all about mutability and immutability. Functions with parentheses. Yeah, this can be skipped as we said. This need not be required. When we specify in this fashion, when I specify a function in this fashion, When I define a function in this fashion, I will say hello Scala. I can call in this fashion, or I can call in this fashion also. Both are a valid thing. Both are a valid thing. Both are a valid things. When we define a function in this fashion, we can either call the function in this fashion or we can call it in this fashion. These are the simple things or simple syntaxes that we are getting used to Scala's functions. Going forward, we'll learn more complex things about Scala. Functions, we'll learn more complex things about functions in Scala. I hope we will end up here. We will continue in the next session. If you have any doubts, please send me a message or call me, or you can email me. I should be able to answer. If I don't know the answers, I will try to evaluate myself. I hope the videos are all available. I'm just uploading the videos. Probably by the end of the day, you should be getting all the videos.